Good morning, everybody, and welcome to today's interest session. Today's topic is on Introduction to Blockchain Technology. And as you are aware, if you've attended these before, the interest program is geared towards short sessions to introduce you to various technologies that are out there in the field. You may not cover them at some point in your, in your work at school or in class or something like that, but there are areas out there and career paths out there that you may want to look at. And to do that, you need to understand the technologies exist, that there's ways to get experience with them, and also that, to understand what the job categories and things like that are out there in that particular technology. So today we're going to talk about blockchain technology, and there's a lot of different, I hate using the word confusion, but that's really what it feels like as far as, differences between cryptocurrencies and blockchain technology itself, and kind of the intermeshing, intertwining of the two discussions. So I want to try to cover that for you today, but also give you an idea of where the work is and where the jobs are and where we think it might be going for you, as a career as well. So these sessions are given to you and provided to you by the ETIC, the Entrepreneurship and Technology Innovation Center. I am the director. I'm Dr. Mike Nizik of the ETIC. The ETIC is located in room 107 of Harry Shearer Hall in the Westbury campus, and any of the services or programs that we run, including interest, as well as the Ursula program, student entrepreneurship program, intellectual property program, things like that, are all available with anybody from any campus. The ETIC is outfitted as a prototyping center to really theorize and build anything that you can think of from a business perspective. So it gives students a great opportunity to work somewhere where they can actually make their kind of visions of product or a service or some sort of technology a reality. We work with students through a number of different ways, including programs like Interest and like Ursula, but we also run different competitions and different hackathons, different ways to engage with organizations before, while you're still at school. Output of some of these programs included students getting internships and jobs. Our Ursula robotics project, working with me directly to produce this program that students use every day in some fashion. That was produced by students and faculty like myself. We also have a student entrepreneurship program. So if you have a company already or you're interested in starting a company of your own, we're able to help students do that. The companies that you see in front of you were companies that students or alum that have had companies or started companies while they were here and moved on with those companies. So it's a great place to engage and get your hands dirty and work on some real technology and kind of use your classroom experience and put it to practice. So take a look if you're interested, nyit.edu/ETIC. Email me directly or contact us, when you're here at Old Westbury for any reason as well. So the topic for today is blockchain technology. And the reason we cover this is because not only is there a big future in blockchain technology, but it's also something that is going to be pretty high demand at a very high level. It's a high skill set type of technology being so new, and also not being well understood for the most part. But the core technologies that allow blockchain to exist are actually things you're learning right now, whether you kind of realize that or not. So today's session is to kind of put that all into perspective, give you a high level view of what the technology is, what it allows to happen, things like cryptocurrency, why there's a career path in it potentially for you. So if we look at something like we have a ZipRecruiter kind of snapshot here over what salaries are out there for blockchain. It's not exactly a blockchain type description of a job. When we talk about blockchain as far as technology goes, we're talking about usually smart contract design, and we'll talk about this, what a smart contract is along the way of this seminar. Smart contracts are designed with proprietary languages like Solidity, but more core programming language that you've already learned and know of C++, JavaScript, and Java, which we use as our core languages in a number of different programs here at Tech. The skill sets that you're learning in your programming courses will be a baseline for you to move into smart contract design, which is how two parties agree on a transaction and then add it to the blockchain. So that concept of adding something to a blockchain solution really works with something called smart contract design. So your programming skill sets will allow you to kind of move into this area if there's an interest in that, based on the core experience you're building as students. And as you can tell, the average salaries that you see there are extremely lucrative for somebody with 3 to 5 years experience. Usually it's what we call senior developers, not senior developers. We don't look at as 20, 25 year veterans. Those are our VPs and things like that. But senior developers are 3 to 5 years. So if you get a year of programming while you're in school, and you move on, and you move on with that to work on some projects at ETIC while you're here too, and then on a same note, you do a year or two in industry, you're at that 3 to 5 year experience level. So it's a very, very lucrative area to start looking as far as that goes. So with regards to programming languages, I always like to talk about this in my seminars to make sure that we understand that there are IDEs, integrated development environments, that allow us to program, work with other programs in those environments, but the languages themselves are unique, right? So the languages, if we look at the top programming languages that we kind of consider the top programming languages now, the JavaScript, Python, Java, C++, and C, PHP, Swift, C#, Ruby, Objective-C, and SQL. Each one of these is its own language that has its own syntax. It has its own packages and libraries that it pulls from to perform certain tasks. But the reasons that we have these kind of popularity in there are for different reasons. So you saw for blockchain, it's one more area you can use C, C++, and Java on top of all the other areas, right? Embedded systems and Windows development and web-based development, right? On top of all the other areas that use those languages, you can also use it for blockchain smart contract design. So on top of everything else, we have this, this ability, which is why we choose it as our core language for training, because it's used so many different areas in so many different industries, so many different levels. So just keep in mind that as you're learning at New York Tech in your classes, you're also kind of preparing yourself for different types of industries and skill sets in different areas. All right, so the way we're gonna work this presentation today is we're gonna talk about the presentation origins, kind of where this came from, why it exists at all, this program. We're going to talk about the history of databases, Bitcoin versus blockchain discussion. That's very important to have. We can also use some other cryptocurrencies, but overall the big one we talk about is Bitcoin. We can talk about encryption and cybersecurity. We're going to talk about blockchain basics. Something I like to call I'm still confused, because even after an introductory discussion, it's still a bunch of hands up saying, what about this, what about that? And then we talk about what blockchain solves, why it's being touted as such a powerful technology, and what business and societal impacts it has, which is rarely discussed, which is the most important driving factor for its popularity. And also some predictions. What do we think is going to happen kind of as things progress very, very rapidly here? Okay, so as far as presentation origins, right, is all these different thoughts and discussions that kind of happen, whether you're at a cocktail party, over lunch at the cafeteria, or in class, all these different areas, all these terms are usually being thrown around, right? So the origin of this was to really kind of put this into some sort of framework that you can have a baseline to kind of move forward and say, I get where all the pieces are, and I understand that piece. Now I can understand where I want to move with this thing. But too many times we're at these discussions and there's just too many terms being thrown around that cross over each other. And we really need to kind of like back up and take a look at this from a different perspective. Right, we want to talk about there's a rapid expansion and acceptance of this. Why is this so unbelievably fast growing, right? What is happening with this? The most obvious thing we see is this increase in value in Bitcoin. And we want to talk about kind of how we do that. And, there's an abstract nature to blockchain. We're kind of looking at this from a very broad perspective, but there's a really unique technology that drives this value of things like NFTs, non-fungible tokens, and things like cryptocurrencies and stuff like that. So there's a technology behind that that we don't really see. We look at the things that are very evident, but what is actually driving it? Why is it so important? And of course, is it all hype? Is it something that we're, this used to be a discussion that was more so about, people saying, is this really that important? Now we're starting to see these values of these cryptocurrencies skyrocket. And now it's really driving the discussion as far as the technology goes to say, why is the value of these NFTs and cryptos so valuable? And it's based on the security and the trust of the technology that exists. Okay. And then we're gonna hopefully get to a point where it's like, okay, now I get it. And then, wow, this is a big kind of concept that we're talking about. And how can I move on career-wise? How can I help everybody else using that? All right. So that was the concept of this presentation, to kind of give you a real broad view of everything, and then also drive you forward, or give you a path at least forward on where you could possibly apply it in your lives. Okay. So blockchain is clearly data driven as a database discussion, but to talk about that, let's set up our history first. For the longest time, when we dealt with anything to do with computer systems, information systems, data was key, right? Still is, obviously, but the programming that we did, right, was all based around not so much user interface as much as it was around the organization of data. And the technologies that drove that data were limited over periods of time, and they're still limited, and we're running into other issues now, today. But in the early days, we had this flat file limitation, right? So we used to have computers that would basically store data on their local hard drives. Really, before that, unfortunately, I remember on tape, which was magnetic tape, and it would reel to reel and go back and forth. And that's an ugly discussion, but we'll just tell you that it existed at some point. But from a flat file perspective, data was kept on a file, inside of a file in a certain format, but it had limitations. It had size limitations. It had access limitations. You couldn't share it with 1,000 users at a time. You couldn't access components of the file. You had to access the whole file and sort through it and then update the file back. As you would access the file from one machine to another, you had to lock it so the other machine couldn't get to it, which caused issues and crashes on that machine. And when the machine crashed, it had the file open. It would just pull corruption. We had to fix the file afterwards. Really a mess, really horrible. However, it was so much better than not having data at all. So we just adapted. We just did what we had to do to keep that running, right? It was so useful to have users at different locations of a building say, this was way before any real hardcore, heavy duty internet access or any kind of VPNs or anything like that. People would work in a building, if you could believe that. So basically we'd work, in a building on different floors, or whatever, but having everybody work in different locations and access this data and share it. I would update a name and somebody would look up the name and see my changes. It was so valuable that whatever the limitations were of the databases at the time were insignificant. We didn't even know that there was a cure for it. We just dealt with it because it was so valuable to have. And those flat files, we saw things, everything from DAT files to text files to, just any kind of a file that would store data in some sort of a delimited fashion. But those files wound up moving into commercial databases like DBase, Paradox, Foxborough, Access. And these were really software-driven databases that were able to be manipulated, but they were proprietary. Each one had their own way of storing data, their own way of manipulating data. So when you had programs that were created that were great programs, they could only talk to one database because they were written around that database. So it kind of made things very, very awkward. Say, I want to use that program, but our data is all in this format, so I really can't. So we needed a standard language to talk to all the different databases, right? So SQL came along, structured query language. And when structured query language came along and all the database companies kind of migrated over to SQL, what would happen is that you could write a program, as long as your program, if it was in Java, C++, Visual Basic, whatever it was at the time, really back then it was COBOL, Fortran, Pascal, things like that. But as long as your program was accessing the data from these databases over structured query language, you were able to talk to multiple databases. One program could could pull data from a Foxborough database, could then pull data from an Access database, and then write it to some other type of flat file that it created on its own, right? So it was really, really a wonderful step in the right direction. But you still had size limitations, and I think it was 2 gig originally, then it boosted to 4 gig, and then, I think it maybe stopped at 4 gig, which, with data, if you think about it, it's 4 gig could be, if you're storing images or video or anything like that, it took up so much space so quickly. So, we needed a way to store the data where it wouldn't be limited size-wise, and we also needed a way so that applications would attach to data centrally and only pull down what they needed, right? It was taking up too much network, it was taking up too much processor speed and memory on the local machines, and it was just too much. So we needed a way, right? We needed a way where we had these relational database management systems, RDBMSs, that actually stored the same data that we kept in these flat file databases, but it was the traffic cop. It would stop somebody here, and it would stop somebody here, and it would give this data to another person, give that data to another person. And basically, as the request came in, this strong, powerful server, the big Dell or HP server or IBM server that we installed with these new pieces of software that ran RDBMS, SQL Server, DB2, or Oracle, MySQL. As we ran those services, we were now allowing users to attach to us, and then we only give them what they're requesting. We're not giving them the whole database like in a flat file, which took up all that bandwidth and computer processing speed, network, and it locked the file, and it corrupted the file, and it locked other users out. This technology, this RDBMS technology, allowed thousands of users to attach to the same database at the same time and actually work pretty efficiently because they were only sending down 2 or 3 records at a time or 100 records at a time instead of 50,000 names and then letting the computer sort through them. Things were also done at the server level at this level, so it allowed lower, more efficient, and less expensive machines to do the processing because the server was doing most of the processing now. But as these databases got very big, and these databases are called relational. So you had one entity that attached to another, customers to orders, orders to order details to product IDs, right? So you had these relational tables, and that relationship between them was beautiful and it was wonderful, but it was heavy, right? It took up a lot of resources to always look into different entities to kind of pull the relationships out. So once the data got into the terabyte realm, where we start talking about data mining, data warehousing, and stuff like that, the RDBMS system kind of broke down. We still use this everywhere today. Every transaction processing system works on an RDBMS system of some sort. But what we had to do is we had to figure out, like, how are we going to process massive amounts of data and order history and things like that while not using the relational system. And that's when we got into NoSQL. NoSQL was the theory at some point, but eventually turned into products like Mongo, CouchDB, HBase, Cassandra. And these are things like Amazon and Google and all kinds of massive organizations that have tons of data that need to search it quickly and, but not use the relational concept, had to go to this NoSQL type process. Now, even when we went to NoSQL, which allowed this single structure to be quickly accessed and sorted and things like that, we still ran into the issue of one single processor or even a farm, even a server farm sharing processors, kind of really doing accurate data searches, right? So we needed another way to another step in the direction of saying we need to very quickly go through a large amount of data, and that's great for a NoSQL database, but now we need to have a distributed process. We need 1,000 machines to sort through this data, come back and give us one result, right? Which is mind-blowing, but that's what Hadoop is. That's what these HDFS systems do. So now we have another data solution, right? So we have RDBMS solutions that are still in existence, will be for a really long time, that do transactional processing and kind of office management type stuff. But when we get into massive amounts of data that have to be sorted and any kind of data analytics and machine learning, all kinds of stuff, we have the NoSQL type solution, which allows us to do that. And then we want to do massive amounts of processing in a really short amount of time on massive amounts of data. We have distributed systems like Hadoop that will spread that query, we'll call it, over hundreds, thousands of machines on the processing end of things. And then those machines will produce back their results. So this is a layout of kind of all the things you probably heard in terms thrown around for data along the way. But it's important to put them into perspective before we move into another data technology called blockchain, right? So, and just to get an idea, client server, whenever we talk about clients attaching to databases, clients attaching to the server, right? The data resides on the server, the client runs the program, okay? And finally, when we take all these types of solutions and we place them on a server that's available over the internet so that we have like a user interface that attaches to the web-based server, and we're able to do these things from a very, very inefficient, inexpensive workstation, right? Tablets, phones, we're able to do this massive amount of data processing off a very simplistic device that's not very powerful. Now we're talking about cloud computing, right? So we're talking about, Amazon Web Services, Azure Cloud Data Solutions, things like that. These data solutions that we just talked about, but placed in a cloud environment on a super high performance system, but you're only accessing them through a browser on your simple device. So we have this amazing, way to kind of say, I'm going to use this simple device, but I'm going to do this massive data processing activities on this cloud-based piece, right? And that's where all these things come together and these terms come together. And it's really where we are today. All of these systems, the flat file, the SQL, the RDBMS, the Hadoop, NoSQL, they're all systems that run and store data. And that data has to be protected. Okay, this is our next phase into blockchain. So all these systems still store data that is plain text data as it's processing. So they have to be protected. Okay, they have to be secured. If we look at the data that's in these things and we put them behind a firewall and we put them behind an intrusion detection system and all kinds of stuff, that's great. And that's what we do on a regular basis to protect our systems. But they're still out there. They're still able to be seen and worked on by internal users and all kinds of stuff. What they don't do for us, they don't provide a way for us to take data and create an immutable, unchangeable, guaranteed, secure data set that we could put out there for the world to see and not worry about protecting it. That's what they don't do. So if we had an unbelievably important data that we wanted to say show a transaction between two people that we wanted to guarantee was going to be trusted in the outside world, sale of a home, sale of a car, exchange of sort of money. Any really important, really valuable exchange, if we have that in our own databases, we're protecting it, there's still risk, right? People are still saying, oh, somebody could have changed it. Somebody could have logged in and changed it. You could have an internal attack. You could have an external attack. All kinds of things could put that transaction in question, right? And jeopardize the value of that transaction and the integrity of that data. Once you take that data and place it into a blockchain solution, we're going to talk about that next. The immutable nature of blockchain says that if you see it in a blockchain public ledger, you have to trust it, because the blockchain community and the scientific community has shown that we cannot reverse that transaction. So because this technology has grown and it's become accepted, it's become tested, and it's become proven, now what's happening is that any transactions residing in a blockchain that is a blockchain trusted network is being accepted as real. It has to be. I exchange 60 Bitcoins and you exchange 60 Ethereum coins, and it has to be. It can't, nobody could have hacked it or changed it or made any edits to it. So I know that Dr. Nizik owns 20 and Max owns 50 and whatever, because it's in the blockchain. It's immutable and we have to trust it. That is what's driving this move towards blockchain technology, because we're taking transactions that are made in our internal area and we're turning them into the blockchain data that's now floating around out there that everyone can see. And it's this public ledger, we call it, that's out there. So let's start talking about that technology now. This lays out the technology for databases, where they came from, where they are now, and how we're going to continue to use it for years and years and years. But now we want to move into the blockchain tech, which then takes the data that we have in our internal systems, and depending on what we want to turn into a blockchain public transaction, a public ledger, depending on what that is, now we have to move it into a blockchain network, because the blockchain network is what's going to protect it. These are not going to protect it the same way. Okay, so we're talking about blockchain technology, and I would say in 2008 it was a paper and a theory and a publication that has now grown to this unbelievable, discussion point at a minimum, right? As far as what we're using it for and what we're going to be using it for. But there are, just to put this into perspective, there are a number of different organizations that have been working since that point to produce commercial level blockchain technology solutions. These aren't cryptocurrencies, these aren't Bitcoins. These are companies that have made blockchain technology solutions that allow us to interact with them and create internal blockchain networks, private blockchain networks, and public blockchain networks. And then whatever we want to put on those networks becomes the valued item. And we'll talk about those a little bit in a second. But basically, whatever the value is that's on the blockchain, that's the value. The technology, the data technology that we're talking about, is what makes those items valuable, because they're secured on the network. Okay, so these are just some companies that are out there that are, if you notice Ethereum, well, Ethereum is a crypto. Well, Ethereum is a crypto and a foundational tool to build your own blockchain network. So these hyperledgers and things like that are all commercial solutions that you're able to use to build your own internal and public blockchain solutions. So let's get back to basics a little bit. Let's not get too mystical with blockchain and NoSQL and SQL and all that, right? Let's just talk about what it is. It's data. So as soon as you remember that there's data, which is data that we don't really know what it is, and then there's information which we apply some sort of a mask to that data that makes it legible. In this case, we kind of say, it's a phone number. I didn't know it was a phone number. Now I know it's a phone number. Then we have knowledge, which we now know Joe Jones's number is 223-4478. Now I know, right, that I can use that. And then wisdom. Do I know Joe? Should I call Joe? Right. The decision to use the data, the newly acquired knowledge from the information and data, right? So data, information, knowledge, and wisdom is what we always kind of wrap around here as the four tenets whenever we think about this. And don't forget that when we talk about data, even when we talk about blockchain data, don't ever let yourself get away from the rows and columns discussion, right? If you've ever taken a database course or anything like that, you've always talked about spreadsheets and rows and columns, and each row is a new record, and each column is a new field, and there's field types and field structures and all kinds of stuff. So don't let it get you, don't let it be too mystical to you. We're talking about a lot of the same stuff here, but there's a very unique and very powerful way that blockchain adapts these things that we've been used to in its process. Okay, so we'll start there as a baseline. Okay, big discussion, but we won't take up too much time on it. Right, Bitcoin versus blockchain. Blockchain technology was designed in order to support the Bitcoin currency, which is where we kind of got blockchain from based on some 2008 work that was published. And this concept then became this powerful technology, okay, this technology that allowed a protected set block of data to be immutable, to be unchangeable, in a guaranteed fashion. That's what blockchain did. Because of that, we applied a value to that called a coin. That block becomes a coin because everyone trusts that that block could never be changed if you know, regardless of the efforts to change. So this block, you know, and the items in that block of data became the Bitcoin, which then held value. So for this seminar, we want to make sure we don't just throw blockchain and Bitcoin around interchangeably. Blockchain is the technology that we use. The reason I say that is from a career perspective, from the interest, from the interest session discussion. Blockchain is now, for a while now, being considered and used in all kinds of different security protocols and transactions for non-NFT, non-fungible token, and non-cryptocurrency related items, right? Supply chain management and all kinds of stuff. So your career path might wind up being creating cryptocurrency type systems, but it's also going to be working on blockchain technologies that are being considered to say, how do we secure automotive, Uber, you know, type transactions? How do we secure wireless systems for cars for automotive to secure those cars so they don't get hacked and accidents caused? So all kinds of reasons we would use blockchain or could use blockchain technologies for that. That's where the career path is most likely going to lie. Okay, so let's talk about encryption and cybersecurity. Encryption is when we take plain text and we scramble it in a way that it's so confusing that really only the algorithm that we use to kind of make the ciphertext is the only way to decipher it. So as a very basic, we just used a simple Caesar shift cipher to explain here. If we took the alphabet, we shifted it one letter, right? You know, your A's become B's and your C's become D's and so forth. It's just a very simple, you know, Caesar shift cipher with a key of 1, just to take whatever the plain text is and make it, you know, make it simple. We're basically sending data over networks at all times. That data is binary data. As soon as we intercept that data, we can turn that data through binary to ASCII conversion into readable data that we can understand, credit card numbers, things like that. If it's not encrypted, if it's plain text, if it's simple plain text. If we encrypt it in some fashion using an algorithm, we make it scramble so whoever gets it has to figure out how to descramble it. Now, in this case, they would solve it in about 2 seconds, but maybe less. But the idea is that we just have an algorithm, whereas our algorithm is to move each letter of the alphabet 1. It's a Caesar shift cipher with a key of 1. That's our process. That's our algorithm, right? But blockchain has an algorithm we're going to talk about next, which makes it unbelievably almost impossible. Really, we should say impossible because the purpose of blockchain is that we haven't really been able to do it. And that's what makes the value of these non-fungible tokens and these cryptos so valuable, because you can't break it. Okay, so this concept of encryption and cybersecurity in general is what we're really looking at. In this example, with the Caesar shift, we're taking the plain text of whatever the value is. Now, that plain text could be an exchange of Bitcoin, an exchange of some value between you and I. That could be the plain text. The fact that on 2/5, you know, on February 5th or on April 22nd or whatever it might be, Mike and Max exchanged 6 Bitcoin. That could be the plain text. But when we turn into ciphertext, we turn into an encrypted piece that encrypted value or ciphertext that is now going to be so difficult to decrypt that we can guarantee that if we see it out there, that it is a valid transaction. Okay? And this is just giving the idea of basically doing some of this encryption. Now, one of the things that we do with encryption, as far as algorithms go, is we use things called hashes. One of them is called secure hash algorithm 256, the 256-bit key. So a bit is 0, 1. So it's 256 zeros and ones that we turn a piece of data into. When we use hashes, right, if you look at some of the descriptions here, right, it's called a message digest. And it winds up being a fingerprint of the original data. Okay, so we use a mathematical function to take some value and turn it into a hash, which is a completely scrambled, erratic, unbelievably, it's called a one-way hash. And the reason we call it a one-way hash is that it's impossible to, there's two things to it. It's impossible to reverse engineer it into the original value. And it's also impossible to get a second hash value that's identical. So SHA-256 has been shown, not all of them, MD5 has been shown to get duplicate hashes and things like that. So there, we don't use those that much anymore. But SHA-256 has been shown to be completely irreversible, and the fact that you can never get a second hash that's identical. There's one more important thing to hashes, is that when you change the original value, even just one character, if you turn an H into a D, if the exchange says Michael and I turn into Nickel, I turn into an N versus an M, the remaining hash, the new hash that it turns into once it's re-encrypted, is completely different than the first one. Not just one or two characters different, just a completely different hash. Just one change of one item on the original value of the text. The secure hash algorithm turns the final result of the hash into a completely new item. So if you look at encrypted data here, when we talk about blockchain, these hashes that we look at, they're 256 bits long, and we would have to try to figure out in some fashion what this really means, what the original value of this means, and then change it and then re-encrypt it and add it to the blockchain. And not only is it impossible to one-way hash, as we change the item, as we change the original value of the item, the transaction between two people, as we change that to show, oh, no, Mike really owns 30 and Joe owns 60 Bitcoins, right? We change that, it changes the actual hash completely, okay? Which means that it's not the original hash, which means the blockchain won't accept it. And I'll show you how that works in a second. So the point for this is that there is a process to take data that's a transaction data that two people want to happen. I want to sell my Bitcoin. I want to buy Bitcoin. I want to buy Ethereum. I want to sell Ethereum. I want to sell my house. I want to buy my car. It doesn't matter what it is. Take crypto and take, anything else, take NFTs, whatever, out of the picture. It doesn't matter what you're selling or buying. What it means is that the details of that transaction, once you put them together and then encrypt them using SHA-256 and putting them in the blockchain, which we'll talk about how the chain works in a second, the world has to accept it as a real transaction. That's why the value of any kind of coin or NFT is being accepted. We just heard recently a non-fungible token is a digital item that's being given value because it's been put into a blockchain. Somebody sold a tweet, an original tweet. Somebody sold some other digital item, right? So these NFTs, these non-fungible tokens, are being given value because they're being put in a blockchain, right? Coins, Bitcoin, Ethereum, and so forth, are being a Dogecoin. They're all being given a value because they're being put into a blockchain. All right, so don't concern yourself too much with the items that are being considered valuable. Consider the technology that is creating the value. Okay, now, how do we create, right? How do we create these encrypted pieces? All right, with C++, with C, with Java, exactly the language I told you about before. Smart contracts are decide how to process data between two parties and then place them in the blockchain using the technology companies we saw before, Ethereum and those actual blockchain technologies, right? So smart contracts are what you'll be creating to add data to the blockchain based on what finance company you work for, based on what asset control company you work for, whatever it might be. Programming the smart contracts between two parties so that when they get added to the chain, that chain is a public ledger that is accepted that Mike bought Max's house, Joe bought Mary's car. It's guaranteed because it's in the blockchain. The smart contract added it, and the smart contract wouldn't have done that if they didn't agree on it. So by having a blockchain existing and by having smart contracts that actually program between two parties to kind of add to the blockchain through these existing technologies that we've showed you, we have a couple of different things that allow a blockchain, especially a public blockchain, not a private one. Like you can have those too, but the public one, meaning the one that we are all kind of used to with the things we hear on the news and stuff. But essentially, we have a centralized blockchain network, which will be run kind of inside of an organization. But a peer-to-peer network is just global. Could be anybody who wants to join a blockchain and process these pieces. Anything that is on the blockchain network we consider it to be, right, to be decentralized, to be synchronized, to be traceable, to be immutable, to be secure, scalable, collaborative, auditable, and programmable. What that means is that once we put something on the blockchain, that item is out of our control and it's part of a bigger network that is being managed. It is synchronized with other parts of the network, okay, to make sure that if one network gets attacked, the other parts of the network know what's missing and things like that. Traceable, we can go back to who created the smart contract, we can go back to who the transaction was between. It's immutable, it cannot be changed. If it's attempted to be changed, it kind of is automatically repaired. We won't get into a deeper discussion of that, but that's really what happens. It is secure, it is scalable. I can add nodes to my network. I can add very easily. I can add smart contracts very easily. I can add all kinds of things very easily once I have the network set up and once I join the network, okay? And it's auditable and programmable. So I can program these smart contracts to behave a certain way. I can make sure that my data in the blockchain is created in a way that services my organization the way I want to serve it, right? In auditable, we have an immutable ledger of what's been done to the chain in the blockchain. Okay, what this winds up doing and threatening, which is another part of the discussion, a non-technical discussion, is that if two people decide to sell a home without a lawyer, one day, without a bank, without the county and without the state, because the data that between them is in a blockchain solution, if all of a sudden the data between the home sale between those two people, because they decided to put it in the blockchain, if the state and the government starts recognizing that value in the blockchain as it has to be a sale of a home, it has to be accepted, you just affected the lawyers, the real estate agents, the banks. It's an unbelievably scary and almost unfortunately realistic possibility that as blockchain solutions get more accepted, if they start being accepted for transactions between people, all those middleman transaction costs go away. Right now, two people have to hire lawyers and banks and town halls and all kinds of stuff because they need multiple copies of things to be in places, deeds for homes and tax records and all kinds of stuff to show that they really truly own that home, they own that car, deeds and all that. If all of a sudden the state decides, the federal government decides that if it's in the blockchain, we're going to accept that just like we would accept anything from a bank, you're turning the entire system up on its head. Okay, so here's the important part, right? We call it a blockchain because we're taking this data between two people, and through a smart contract, we're creating this encrypted block of data that represents that transaction. It could be a series of transactions. Let's take one transaction. Once that block is added to a chain, other computers, other processors called miners, they validate that the encryption done on that block before it got added to the blockchain is valid. It's called proof of work. So as a miner, I can attach my computer or a series of computers. People use NVIDIA cards now, and they have these mining systems, and each system is going out and attaching to a blockchain network, and it's looking for data that hasn't shown proof of work yet. It's looking at a certain location. And when it finds that block, it's running a mathematical algorithm on that block to prove that the encryption algorithm, the SHA-256 hash algorithm that was performed on that block is correct. And as soon as that machine, we'll just call it a machine for now, whatever format they're using, proves that that block is correct and is immutable and cannot be break, then is it added to the blockchain, which it becomes part of the chain. That block in the chain, once that block gets added to the chain, if this was Max and I, if this was our exchange of our home sale, this home sale points to 52. This block 53 has our home sale in it. Block 54 and block 52 also have our home sale in it. Block 53 also has block 52 and block 54 in it. If somebody breaks block 54, block 53 knows how to repair it. If someone breaks block 53, which is our home cell, block 52 and 54 know how to repair it. So when you break the chain, trying to kind of hack it and damage it and whatever it might be, the other blocks in the chain know how to create it. That's why it's considered immutable. That's why it's considered secure. That's why it's considered, if I read the data right out of the blockchain, I can't reverse engineer it and change it and then re-encrypt it and upload it to show that Mike doesn't really own the house anymore. Can't do it. I can't do it. And if I just try to erase the sale, I don't want the sale to exist between Mike and Max. And I try to break it, the other two repair it and say, no, somebody just delete the block, we have to repair the block. Right? So once the smart contract gets created and adds between two parties some sort of transaction, a Bitcoin transaction, an Ethereum transaction, a home sale transaction, a car sale transaction, once that transaction gets created and added to this kind of, we'll just call it a queue, as soon as the proof of work is done from the miners and that block is considered legitimate, right? That block is added to the chain. Once it gets added to the chain, it also gets added to the blocks where it inserted. So now, as soon as somebody breaks the chain, the other two blocks repair it. So as soon as the proof of work is done, it becomes a valid part of the network. And once it's part of the network, you can't remove from the network. You can't make changes to it. You can't make adjustments to it. Right? This blockchain technology, combined with the smart contract user input, and combined with this SHA-256 hash algorithm that protects the data before it ever gets to the blockchain, okay? That's what makes this network and anything on this network so valuable, because you have to trust it. If I took my tweet from, I don't know, from 2014 that has some sort of value to it, to a community, and I turn it into a part of a blockchain and it's truly original, that becomes an NFT, a non-fungible token. That token is worth something to somebody because when they buy it, they're not buying a physical item, they're buying a digital item, but because it's on a blockchain, it has value because no other token is going to represent that tweet, right? This is how the technology works. This is where the career path is. Different people are going to use it for different fashions, different ways to produce value in these non-tangible items. We know that we have work being done in an organization using smart contracts to create these blocks to put in a queue to be mined and then added to a chain. And we know that they're 256-bit hashes that we wind up putting up there and showing proof of work for. But this is a snapshot from a Rush data mining, a Bitcoin mining operation. I kind of found it online. I thought it was cool. But this particular operation, all these machines are attached to the public blockchain ledger, looking at the queue and doing the mining and proof of work on all those. The reason that they're doing it, investing the money in the equipment and in the management of it, and the configuration of it, and the energy used by these things is enormous. The power consumption of these things is enormous, but it's still worth it to a lot of people because they're getting paid in Bitcoin every time they, or Ethereum, every time they show proof of work and add them to the chain, they get paid in a percentage. Usually it's not a full Bitcoin now, but it's a percentage of the Bitcoin as far as what the value is that they're paying for you to kind of attach. So that's why you can't get a really good graphics card right now from NVIDIA, because they're all being bought up by the Bitcoin miners to do that. Okay, but essentially we're taking this data, the mining solutions are attaching to the public ledger, and they're showing proof of work on this. And then those blocks, when they get added, those blocks are pointing to each other. So the data from block 1 is also in block 0 and 2 in this case, and block 2 has block 3 and block 1 in it. So as you break the chain on purpose or even by accident, the rest of it repairs itself, again, which makes it immutable, even if you actively try to change it. So this is the piece we call "I'm still confused," and at some point there's probably still some confusion in this piece. So let's go through this piece. So A and B, right? Person A and B want to conduct a transaction. Okay, there's cryptographic keys that are assigned to A and B. The interaction is broadcast and verified by a distributed network. Once validated, a new block is created. The block is then added to the chain, and then the transaction is complete, right? So what did we just talk about? We're agreeing to a transaction, so we're using a smart contract to create it. We're adding it via the smart contract and whatever blockchain commercial technology we're using, Ethereum as an example, where we're using that, it's being added and broadcast to a distributed network. It's validated, it's mined, okay? Then it's added permanently to the chain, and then it's immutable. These two people, whether they wanted to or not at this point, have record and have evidence of that transaction happening. If courts and state and federal government one day recognize what's in the blockchain as legal, that's the challenge. If they start to realize and recognize that the value of transactions in a blockchain are representative of the real transactions and are entertained in a court of law, that's when the world is going to change. Because if Max and I decide to sell our home in our first example, and we agree to do it on a blockchain network, and we've sold our home and the money's transferred and everything, if the courts also acknowledge that, then I said, you didn't really buy my home. Now I can't do it because the banks and the state and the county and everybody has these laws in place. But there's no laws for blockchain right now that will allow that. But if there were, Max couldn't just ask for his house back because of our agreement, he didn't like our agreement. I would have permission from the court to say, no, my house is mine, it's in the blockchain, there's proof of the transaction. With Ethereum, we have a Solidity proprietary language for creating smart contracts. So if you're used to coding in C, C++, Java, the format and the syntax for Solidity is pretty familiar. Even if you know Python, it's actually similar to that as well. So when you're using Ethereum and you're programming your smart contracts through the Ethereum interface, right? All your programming concepts, loops, conditionals, data structures, things like that are in place, and you can learn this new language as far as what you're doing there. Career path, right? You can get going on that. Take the mystique out of the whole thing. Just realize that, yeah, we're talking about, Bitcoin and blockchain and NFTs and blah, 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 blah. I get it, but there's a real core technology that makes all these other things possible, okay? Tomorrow, it's not Bitcoin, it's something else. It's ABC coin. ABC coin exists as a value and entertained by people because of the blockchain technology that we covered today. And that's where the career path lies, in programming smart contracts for blockchain, so that whoever next decides to make some valuable item, secured in a blockchain, whoever, could be Bank of New York, could be Bank of America, it could be Chase, it could be whoever, you have a career path with them because you know the structure and you also know how it's created. Another example of how these smart contracts are kind of created and look and feel. Again, we won't go through the process of what we're really saying here, but if you look at it, it's interface based. So if you know the Java interface concepts, we're not really programming core concepts and core materials into the smart contract. We're dealing with interfaces that already exist. We're passing data from our users into the interface. The interface is processing and it's called abstraction and data hiding. Those of you who are gone through our programming courses already, but in those processes, we're passing information into an interface, it's processing, it's doing its job, and it's giving us back results, and we're using those for something else, so sort of an access log or something, right? So, so not so far off from what you've been doing in class at some level already. So, okay, a little more non-technical. What does it solve? It solves trust issues on transactions and contracts. If something's in the blockchain, there's really no disputing it, as long as you agreed originally to have it. If it's in the blockchain, someone brings it up later on, you kind of got to accept it because nobody would be able to do anything to it, to show, to alter it, to edit it. The high cost of transaction fees goes away. If this becomes accepted and recognized by government, the high cost of transaction fees for middlemen, for insurance agents and brokers and real estate agents, it's all that work that they do to make something legal, right, goes away, which is scary. The need for service professionals, anybody who plays any role at a bank, at a government, if all of a sudden these systems get recognized as legal of ownership of transactions, there's a big global change to that. Cybersecurity, all the effort and time and efforts and costs we put into protecting data now goes away because things are in the blockchain, which means that have at it, go hack away at it, because I don't really care what you see or what you don't see. You can't change the data that I'm considering secure, right? And the concept of no data loss or damage that's in that statement I just made. And there's a number of business and societal impacts that we're going to see here, right? No more questions about ownership, no more questions about validity, no more service providers, no more transaction fees, no more fear of data loss or theft. These are big philosophical discussions. I don't totally agree with or think that a lot of these are going to ever happen. I just don't think that that's a reality. Short term, for sure. But even long term, I think there's always going to be a need for some sort of transactional system, record keeping system. But really, that's what's being touted. And that's what's being talked about. And that's what all the discussion is about, is that if this goes the way that we think it's going to go, and it becomes accepted as a legitimate record keeping system that shows true transactional ownership, we've got a lot of work to do, because we're going to lose a lot of service, kind of middlemen type concepts, middle person. So, some predictions, right? The major players will continue to release commercial applications for business. I showed you a bunch of them. They're going to continue. This concept for products that create smart chains, smart contracts, and add them to blockchains are going to grow. Modules will run extremely slowly and cautiously. Blockchain will be tested. We're going to continue, to always try to find ways to break blockchain, which is what's been going on at research institutions for quite a while, to try to make sure, try to see how much damage we can do, what are the weak points, what are the holes, because if we don't identify all those, we can't really truly tout it as an immutable system. And eventually blockchain will replace certain database functions of all businesses, big and small. So anytime we have data that we're trying to make available to the public, but we're always worried about its security, I believe eventually that's all going to be replaced by blockchain. Anything that we want people to see on purpose, website data and everything else that we see, I do believe that will all be replaced by blockchain. And I do believe, prediction-wise, that local transaction processing systems will always remain some sort of RDBMS. And the reasoning is, the work involved to create the encrypted data and then to show proof of work on it is enormous. It could take anywhere up to 10 minutes to a half an hour to prove one block of data. And that's unacceptable for a long time now to come. If we're using the high-end processors to do it now, it's not going to be acceptable to, transactions right now, go to 7-Eleven, buy a cup of coffee, it's a millisecond. That can't be handled in blockchain that way. Okay. All right, so with that, I'm going to conclude the session. I thank you for attending this interest session on blockchain, and look for our future events. And I look forward to seeing you all again soon. Thank you, and have a great day.